And welcome, spaced out viewers. Lots of exciting stuff going on today, including filamentary eruptions, CMEs, a CME watch, new sunspots forming, and more. Filamentary eruption here in the southern hemisphere. It was happening when we made yesterday's video. And it did not produce an Earth-facing coronal mass ejection. You can see a new sunspot growing in the northern area, and we've got a new most likely spot for major solar flares as a result of that. Also, a possible new sunspot group forming over here. So we're up to about 5 sunspot groups, possibly. But we've certainly got 4. And at least 3 of the 4 are already beta class. So the likelihood of large flares has gone up precipitously. The radio flux has gone down since yesterday, but that's going to come up quickly as well, with as many sunspots as we currently have on the Earth-facing portion of the disk. And this one's pretty interesting and pretty complex already. Again, likelihood of solar flares rises a lot as a result of that, and we've also put up a coronal mass ejection watch. So here's the filamentary eruption that happened yesterday. This was in the process of fully leaving the corona when we made yesterday's video. There are still significant plasma filaments that could eject and are very likely to, which is why we've put up a coronal mass ejection watch once again. Spectacular imagery there from the SDO in ionized helium wavelength, 304 angstroms. And you can see the disparity in helium around those sunspots. Here's the formation of this new sunspot group. It is beta gamma delta class, I believe, at the moment. It is in the process of perhaps still growing there. It looks like the leading umbra, especially, the radio flux is only at 90 at the moment, 10.7 centimeter radio flux. There's the 1-year chart of that to put it in context for you. That's from Solon.info. You can see on the Space Weather Enthusiast dashboard, no space weather storms or geomagnetic unrest in the forecast. Some seismicity here, upticked in the past couple of days. We did see a break in the 7 magnitude earthquake drought, and we saw a 6 magnitude quake come in yesterday. So there's that 6.3. Smash Team would have already been aware of this, smashamash.com/smashteam. And we've got some quakes in the middle of the U.S. here. They're not large enough to really report on, but you can see them there on the map. Deep quake at Vanuatu, it's only a 4.6. There's a 5.4 north of New Zealand. Colombia, a 4.9 at depth. .1 at the Philippines. And there's one at New Caledonia, a little bit northwest of New Zealand there, in between Fiji and Australia. And the second largest quake of the past 24 was an aftershock of that 6.3 magnitude quake. This time we're going to go up the list in volcanoes instead of down. Novato State, Chilean, we're unable to detect if it's erupting. That's located in central Chile. Sabancaya, also unable to detect. That's in Peru. Must be cloudy. Satellite imagery not clear on those. Revenador is exploding. 15,000-foot ash plume from Revenador in the nation of Ecuador. Flight level 150 over Revenador. Novato del Ruiz, flight level 200 as it explodes. That's in Colombia. Fuego, flight level 150. The Guatemalan volcano producing a 15,000-foot plume of volcanic ash. Color code raised to orange, although no eruption yet at Ulawun on the Papua New Guinean island of New Britain. Suwanosejima, unknown volcanic ash cloud from Suwanosejima. And Kirishima. Kirishima on the Isle of Kyushu. Some volcano tectonic earthquakes happening there. A little earthquake swarm under Kirishima. And last but not least, La Palma has been overflowing some lava tubes and overflowing some old lava fields. So some additional real estate being created there. There's one of the overflows at La Palma. Follow Invulcan on Twitter. Invulcan will include some additional scenery of that if you want to go look more at La Palma. Quite a spectacular eruption there. I'd like to go visit. And remind you not to pole vault the caldera. If you're going through hell, keep going. And if you're over Earth, perhaps join the Galactic Special Forces. Tell your friends and foes, Universum Liberate. Yes, Universum Liberate, folks. You can probably figure out what it means. As you're watching this video on the internet, this is a YouTube exclusive, by the way. The space weather videos at the moment are only available on YouTube. And we're paid just this side of nothing to tell you about what's going on in space and with the sun, forecasting, and so on. So perhaps get serious with your gift buying and pick up some Universum Liberate gear. The print quality is quite spectacular. Is it time to join the Galactic Federation Special Forces? If so, tell your friends and foes Universum Liberate with some gear. Or perhaps become a member of the Smash team. Support the channel that way. We've replaced Patreon with something vastly superior. Smashamash.com/Smash team. You can find links to it on the homepage at smashamash.com. And welcome viewers to the Neo Renaissance. Congratulations on realizing that the channel exists. You, our viewer, are a bunch of magnetic personalities, so leave us comments and amuse us with your witty retorts. Next, the GOES magnetometer. Over the past 3 days here, fairly smooth readings. There is no major plasma in between the sun and the earth except in filamentary form. And let's take a look at the heliospheric current sheet here. And we may see some changes coming here, especially with that pretty significant sunspot group in the northern hemisphere. But at the moment, Earth is in a North Pole current sheet shown there in green. No changes expected immediately in that. Keep in mind the magnetic environment can suddenly change. Sunspots can evaporate and other ones can appear more quickly than we can make a video about it, frankly. Anyway, there's the line of sight view of the current sheet. Red is South Pole oriented current sheet. Green is North Pole oriented plasma. And here's your line of sight coronal hole plot. And you can see those very substantial North Pole oriented coronal holes there. They're extending below the equator. We can expect some significant geomagnetic effects from those. We can expect to see some aurora borealis, most likely, from those. That's a lot of coronal hole area there as cycle 25 progresses in earnest. So you can see some great definition there in the 193 angstroms view of those coronal holes. And that filament was actually right on the leading edge of that coronal hole. And I would remind our viewers that one of the features of these is that there are solar protons blasting out of here at very high rates of speed. So as that turns, that's creating an aspect of the heliospheric current sheet. In other words, there's a high-speed, essentially cosmic rays. There are high-speed solar protons being emitted from that coronal hole there. And some of those are going to reach Earth in about 4 days. So we can expect some effects from that, but in the meantime, we can expect some solar flares as well. You can see the likelihood of solar flares up here over 60% now, and it's largely a result of this new sunspot here, which is going to be named 2902. 2902 is the one to really keep an eye on. It's beta gamma class, and when I say ion, well, pardon the pun. Solar flare watch and coronal mass ejection watch in effect, folks, as the sun ramps up activity. Sorry to all of you saps out there who don't want to see any sunspots, because you would rather be right than have things behaving normally with the closest star. Here's the X-ray profile over the past 3 days. Don't be a sap. Watch our videos instead of watching nonsense on YouTube, because there's a lot of nonsense on YouTube. So just avoid that and watch our videos and refer them to people who don't spout nonsense. We'll put them on the channel. So no flares. You can expect some. No spikes in the proton flux. And without flares, you can't expect any. How about the real-time solar wind? Let's break it down. It was a little busted yesterday with missing data, so we didn't feature it. We featured a still non-live image as opposed to this active applet. Oh my God, it's nearly 6.66 protons per cubic centimeter for the solar wind density, which means it's a pretty diffuse solar wind there. 333 kilometers per second is the solar wind speed, so it is a slow and rather backgroundish solar wind at the moment. The rest of those panes unremarkable. The top pane, the BT of 3, is a fairly weak total field, and a BZ of 0 means we have pretty much equivalent magnetism from both solar poles. KP index is at 1. That's a measurement of global geomagnetism, if you're wondering. And let's take a look at Earth's magnetic moment from space. Space Weather Modeling Framework models velocity and density and magnetohydrodynamic pressure. That's the frame we're looking at. Nanopascals is the units. I guess nanopascals are the units. Most of the pressure here in the magnetotail side, homogeneous pressure for the most part over the past 4 hours. And like the last frame, this is also 4 hours of data here. This is ground magnetic perturbations in nanotesla. Changes to Earth's B field, known as geospace delta B. We showed you the sun's B field on the coronal hole plot. Here's the Earth's B field on the surface, at least. And no major perturbations there, magnetically speaking. No real surprises there with the solar wind in its current state. So, here's what's going on in the solar system. We're going to show you the coronal mass ejection from yesterday here in a moment. First, a forecast for where planets will be. Here's where things will be in 7 days, and we hope that you're not frightened of planets. And next, we've got a star chart. Let's draw some things in. And that's better. We've drawn in the ecliptic and the galactic plane, and we've shaded the galaxy. I believe we've got Mars here. Oh, it's the moon. So the moon is quite low in its path across the ecliptic here, that yellow line. Today the sun will rise into Virgo. And after passing through Taurus, we'll set here in the Lehigh Valley. That's in-the-sky.org. And let's do a cosmology segment. As we're getting a little bit deeper into space here, the random object today is number 66, which is a Seyfert 2 galaxy, a type of active galactic nucleus known as NGC 788. NGC 788 is an X-ray source, and it is monitored by the Neil Gehrels Swift BAT X-ray Observatory. That BAT stands for Burst Alert Telescope, by the way, folks. And there is your 16-year chart of its X-ray output. You can see it's quite consistent. And let's take a look at it visually. So here it is on the CDS portal, and that's the view from Pan-STARRS. A great high-resolution survey there. Doesn't really look like a spiral galaxy so much, more like an elliptical galaxy. Let's look at some other wavelengths. Here's the 2-mass, which is infrared light. The thermal spectra of NGC 788. It's a type of active galactic nucleus there. It's an X-ray source. And how about ultraviolet? Oh, and it's a ring galaxy. So this is an interesting feature here. This is quite an uncommon feature, actually. It's a ring galaxy. So you can see that it's got a lot of UV emissions around here, and a lot of UV emissions here, and some missing UV emissions in here. So that's gives us some insight into the structure of this active galactic nucleus. Perhaps it's giving us some kind of insight into maybe its interaction with its local environment, right? We've also got these sort of features like this in the ultraviolet spectrum. So maybe it's in the process of becoming a spiral galaxy. And galactic evolution is a fairly misunderstood or non-understood thing. And here are false color images of it in X-ray, and you can see it's quite a bright X-ray source with respect to its other galactic companions. Anyway, that's today's featured cosmological object, galaxy NGC 788, entry number 66 at the Neil Gehrels Swift-Bat X-ray Observatory. And let's take a look at the astronomy picture of the day. Now, that's not Titania McGrath, the famous Twitter account. And leave us a comment if you follow Titania McGrath on Twitter. If you're wondering who Titania McGrath is, she is a fictional person, which is basically a parody account of a woke person on Twitter. I'll just leave it at that. So I have not pre-screened this astronomy picture of the day. It's actually an astronomy video of the day showing the motion of Uranus and the moons. So we'll just mute this in case there's any kind of very nice, very nice. So the motion of Uranus, as well as Ariel, Titania, Umbriel, and Oberon. Yes, very cool. And that is from the Beresfordbury Observatory in Hertfordshire. Some difficult to pronounce names there for Americans at the British Observatory there in Beresfordbury. By the way, if you don't follow us on Twitter, you should. If you're not on Twitter, get on Twitter. Why not? It might not be as bad as you think. The censorship is pathetic. However, if you follow the quote rules and quote, of course they'll be disproportionately applied to you depending on what you're into, but hey, if you quote follow the rules and quote, you probably won't even get banned. Let's take a look at the coronal mass ejections we were talking about yesterday from stereo A as well as the LASCO C2. So here's stereo A on the left, which is located here at Lagrange point 5. Here's the LASCO C2 located at Lagrange point 1 in between the Earth and Sun. Also a great view of Mercury showing up there on the LASCO C2. So it was a very minor filamentary eruption yesterday. Barely even noticeable here, sort of a stealthy coronal mass ejection and not likely to strike the Earth. And even if it did, it wouldn't really do very much, especially with a coronal hole wind stream chasing it. So in any case, there's the coronal mass ejection profile. There is a coronal mass ejection watch in place because the likelihood of additional coronal mass ejections is certainly very, very high. This may change to a warning later today. And if you want the latest updates on this sort of stuff, become a member at smashamash.com/smashteam. We'll be putting up all kinds of public posts throughout the year 2021 because 'tis the season for giving content. Let's continue on. Now that the cosmology segment's complete, we would invite you to check out our playlists, as this cosmology segment was integrated into a daily space weather video like many are. And there's lots of stuff to look at, so we're looking at it on the regs. No charging hazards at the moment, which means any kind of communications failures, you could blame about China and Russia. Okay, China. Please leave a comment if you're unnecessarily frightened of China. All right, here is the relativistic electrons over the past year. That's from Solon.info. We're at low levels here. There's a 3-day chart measured by the GOES 16 and 17 using radiography, measuring the electron flux at the ionosphere layer, around the F layer, around 300 kilometers of altitude from their geosynchronous orbit. Their geosynchronous near equatorial orbit, the GOES 16 and GOES 17, measure the electron flux using radiography. Here is the forecast model. NOAA forecasting flat levels of electron flux here, and I would tend to agree. Next, a diagram of Earth's Van Allen belts, because we're going to show you the total electron content forecast here, showing you the most likely places for GPS errors on a scale from blue to red. The redder it is, the more likely for a GPS error. And we typically see the most anomalies when we see low levels of electron flux like we're at now. I'll let it play through a second time. Basically, folks, if you're in a place with GPS errors, make sure you have your location accuracy turned on to use Wi-Fi hotspots. And as long as there are Wi-Fi hotspots and you're in a location that's not too desolate, you should be able to get accurate location services. And then when you're not using them, just turn off your location accuracy and turn off your GPS to conserve batteries. Next, a diagram of the atmosphere here showing things like electromagnetic penetration, temperatures, and chemical densities in various layers of the atmosphere, because we're showing you the F layer next. And here is the vibrational frequency of the ionosphere at about 300 kilometers of altitude, the location of the F layer. Don't be effed. Watch our videos every day and understand how the variables tie together. We've got significant anomalies here, especially around the southern hemisphere, mainly of the high-frequency variety as far as I can tell, but there are probably some wild swings there as well. Low-frequency anomalies are a little bit less evident on this view. So let's take a look at the anomaly map. And there's the anomaly map. This is anomaly in megahertz from the 30-day median. We're seeing some low-frequency, high-frequency shifts down here around Antarctica. And I don't remember seeing those before, so those are sort of a new anomaly. We do look at the ionosphere daily on our daily space weather videos, which we're pushing 4 years of missing, like, I think 1 day over that entire period. So anyway, there's the latest image. That's 9:30 Universal Time ionogram. And there's the anomalygram. Ionogram, anomalygram. And you can see at the moment there, Central African high-frequency anomalies, North African low-frequency anomalies. That's the way the ionosphere crumbles. That's the way the magnetosphere behaves. And let's do bonus features. And the first bonus feature is ground-based solar observatory imagery from El Teide, Spain. That's hydrogen alpha. Let's move on. Here's the NASA GOES 16 SUVI. And you can see right here, filamentary activity kicking up. That's the kind of thing that makes you put a coronal mass ejection watch in place. Coronal mass ejection watch. It could turn to a warning as quickly as it turned into a watch, which was quite quickly. Here's the latest intensitygram and the latest magnetogram. So those are serious sunspots. This one has actually degraded, but these are close enough that they may interact with each other anyway. This one up here is quite promising for producing flares. And we've got another one forming there. So indeed, that's another beta class sunspot group. Likelihood of solar flares quite high. That's an alpha class. That's unlikely to produce major flares. We'll do a little magnetic field crawl here. Some maximum resolution imagery there. That's 4096 by 4096 pixels. And that is quite an active sunspot. Here's the Southern Hemisphere in composite imagery for the past about 24 hours. Great view of that filamentary eruption in ionized helium and iron. Here's ionized iron by itself. And here's a Northern Hemisphere in composite. We'll close out with a Northern Hemisphere in 171 angstroms. Fortunately, we don't have to pick a favorite wavelength. We just cover the ones that are the best for whatever phenomenon's happening. It gets pretty complex, folks, and I've known since the 1990s that it would be pretty tough studying heliophysics. I finally got around to it. Thanks for joining me. And may that solar wind be at your back. Opinions expressed in this video and on merch, not necessarily the opinions of Smash News Network, least busted. Name it news.